Have you ever felt like your organization is drowning in data, but absolutely starving for answers? I mean, you've got sales figures, web logs, customer feedback, just terabytes of the stuff. But when someone asks a simple question like, hey, who are our most profitable customers? All you get is silence? Well, that is a classic sign of a missing blueprint. And today, we're going to sketch out exactly what that blueprint is. Data architecture.
This quote, man, it really just hits the nail on the head. Without a plan, data just becomes this messy, chaotic pile of information that's impossible to make any sense of. Data architecture is the thing that tames that chaos. It makes sure every single piece of data has a purpose, a place, and a clear path to becoming a genuinely valuable insight.
So how does this all work in the real world? Honestly, the best way to get it is to think about building a house. You wouldn't just start throwing bricks and wood together, would you? Of course not. You need a team, and everyone has a specific job. Well, in the world of data, it's pretty much the same. So let's meet the crew.
First up, you've got the data architect. This is your master planner, the one who designs the blueprint. They decide where all the rooms go, how they connect, and what the whole structure is going to look like. Next, the data engineer comes in. They're the construction crew. They take that blueprint and actually build the thing. The foundation, the walls, the plumbing, all of it. And finally, you have the data scientist. They're the one who moves into the house and uses it to discover amazing things, to analyze and to find those insights that push the business forward. So it's simple. One designs, one builds, and one uses. Okay, so analogies are great, but let's get down to brass tacks. What are we really talking about? Data architecture is the official rulebook for an organization's data. It's not just one diagram, it's the whole shebang. A complete set of standards that dictates everything from how you collect data to how you store it to how you keep it secure. And here's the crucial part. A good architecture is built to last. It has to be scalable and ready for whatever comes next.
Now you know, these blueprints haven't always looked the same. Not at all. Just like building materials have evolved from wood and stone to steel and glass, our data materials have changed dramatically too. So let's take a quick walk through history to see how data architecture has had to evolve just to keep up.
It all kicked off back in the 70s with the foundation, the relational model. That was all about organizing data into neat, tidy tables. Then, in the 80s, we built the first data skyscrapers, data warehouses, to centralize all that structured data for reporting. But then the 2000s hit, and the internet gave us this tidal wave of messy, unstructured info we call big data. A whole new tool, Hadoop, was invented just to handle this chaos. By the 2010s, the cloud changed everything, giving us super flexible data lakes and way more powerful warehouses. And that brings us to today, where we're exploring wild new frontiers like the data mesh. You see the pattern? Each step was a reaction, solving the problems the last generation couldn't handle.
All right, let's zoom in on the two big ones you'll hear about constantly today, the data warehouse and the data lake. Think of a warehouse as a perfectly organized library, where every single book has a specific spot on a specific shelf. A data lake, on the other hand, is more like a vast natural reservoir. You just pour all your data in, raw, unfiltered, structured or not, and figure out how to use it later. Now, this right here, this is the absolute core difference between them. It all comes down to a concept called schema. A data warehouse uses what we call schema-on-write. That means you have to define the structure, the blueprint, before you put any data in. It's like building all the shelves in your library first. Every book has to fit into a predefined category. A data lake, though, it uses schema-on-read. You can just dump everything, books, articles, videos, audio clips, whatever, into the system in its raw form. The structure only gets applied when you actually go to read it. It gives you incredible flexibility, but yeah, it takes more work on the back end to make sense of it all.
And this table just lays out the practical trade-offs perfectly. Data warehouses are amazing with structured data for things like business intelligence and reporting, and they're usually super secure because everything is so well defined. Data lakes, on the other hand, can handle any kind of data you throw at them, which makes them perfect for machine learning and data discovery, when you're not even sure what you're looking for yet. The point is, one isn't better than the other. The choice of blueprint depends entirely on what you're trying to build.
Creating one of these blueprints isn't something you do in an afternoon. A data architect doesn't just draw a single diagram and call it a day. It's a whole process, a journey, that moves from a really high-level vision all the way down to a detailed, ready-to-build plan. Let's break down how that unfolds across three key levels of design. It all starts here,
with the conceptual model. Seriously, think of this as the architect's first sketch on the back of a napkin. It's super high level. It's just identifying the main things the business cares about, like sales, product, and store. There's no technical jargon, no database details. It's all about capturing the business point of view.
Okay, next we get a little more granular with the logical model. This is like the detailed floor plan of the house. Now we're still not worried about what kind of database we're going to use, but we are defining the specific pieces of information, the attributes that make up each of those big ideas. So for product, we're adding details like product ID and unit price. The relationships are getting way clearer now.
And finally, we arrive at the physical model. This is it. This is the full-blown construction plan that you hand over to the engineers. It translates that logical plan into a specific technology. Notice how we're now seeing technical details like integer and varchar. Table names are locked in, column types are defined, everything is specified for a particular database. This is the blueprint that actually gets built.
So, we've gone through the what and the how, but that brings us to the most important question of all, the why. Why go through all this meticulous planning? Why bother with all these layers? Well, the answer lies in one of the most fundamental principles of design. This is a classic mantra in architecture, and it applies perfectly to data. What it means is that the design of your data architecture, its form, has to be driven by its purpose, its function. You don't choose an architecture because it's the cool new trend. You choose it because it is the absolute right tool for the specific business job you need to get done. Let's make this crystal clear with two quick examples. If your business goal, your function, is to detect fraud as it happens, in real time, you can't use a slow system that updates once a day. Your form has to follow that function. You'll need an architecture built on streaming data pipelines. But if your goal is regulatory reporting, speed isn't the priority. Accuracy, auditability, that's what matters. In that case, your form would be a highly structured, traceable data model. The why always determines the how. So here's the bottom line. Data architecture isn't just some technical exercise for the IT folks. It's the fundamental framework that allows a business to actually listen to what its data is trying to say. Without the right structure, all those powerful stories, insights, and answers just get lost in the noise. So the final question you have to ask yourself is this: is your architecture actually built to listen?